So we're looking at the function f of x equals x squared minus x minus 2. That whole quantity is over the whole quantity x squared minus 2x plus 1. And we want to discuss what's going on vertical asymptotes and horizontal asymptotes if they exist. And so looking at this, first thing I would do is factor both my numerator and denominator. I want to try to find values which set my denominator equals 0, but not my numerator. Only way I can see that is if I factor this. And so looking at the numerator, this is a quadratic. So I'm looking at, and my coefficient in front of x squared is 1, so that's the nicest case. So what multiplies to give me my constant -2 adds to give me -1. Well, what multiplies to give me -2 and adds to give me a -1 would be a -2 and a +1. So that numerator factors as the quantity x minus 2 times that quantity x plus 1. The denominator, again, I have a quadratic. Coefficient in front of x squared is 1. So I'm looking at two numbers that multiply to 1, but add to my middle term -2. So -1 times -1 is +1. -1 plus -1 is -2. So this can be factored as x minus 1 times x minus 1. Let me just make sure I had written this down right. I did. So looking at this, I can see that I have a value which sets my denominator equals 0, but not my numerator. And so I can see that I have a vertical asymptote. At x equals -1. Well, let's look at what's going on the left-hand side and the right-hand side of -1. So if I'm looking at the limit as x is approaching -1 on the left-hand side, I need to think about what's happening. Is this going to blow up to positive infinity or negative infinity? Okay, well, if I'm plugging in -1 on the left-hand side, this is numbers that are values of x really close to -1, but less than -1. So let's think about this. So if I plug this negative number into this x value -2, that's negative. So that piece of my numerator is negative. If I choose a number less than -1 and I plug it into my x plus 1 value, so something smaller than -1, that's going to make this piece x
Sorry,
plus
ma'am.
1 negative. Yeah.
I think the vertical asymptote shall be x equals 1 because x minus 1 doesn't make the denominator 0.
Hold on, let's see. Yeah, I made a mistake here. X equals -1. That makes my denominator or my numerator equals 0, but not my denominator. This should have been x equals +1. That's what sets my denominator equal to 0. So let's try this again. So going in for values of x to the left of 1, those are values of x which is less than 1. So if I choose a number less than 1 and I subtract 2 from it, that's still going to be negative. If I choose a number, though, that's less than 1 and I add 1 to it, that's going to be, well, that really depends, right? Oh my goodness. Let me just think about this. Okay, so anything that is close to 1 on the left and I add it to 1 is positive. Anything that's close to 1 to the left of 1, though, is going to be, and -1, that's going to be negative and a negative. So here I get a positive, I'm sorry, negative times positive is negative. All over negative times negative is positive. So this is equal to negative. this is going to be going down to negative infinity. Where if I look at the limit as x is approaching 1 on the right-hand side of f of x, so 1 close to 1 minus 2 is negative. 1 close to 1 plus 1 is positive. But I have something bigger than 1, and I'm subtracting 1. That's positive. Bigger than 1, close to 1, but subtracting 1 is also positive. So I get a negative number over a positive number, which goes to negative infinity. Which is telling me if I looked at the graph at x equals 1, there's a vertical asymptote here. And my graph is shooting downwards as I get closer and closer to negative 1 on the left and on the right. So that's what we know about the vertical asymptote, but now looking at the horizontal asymptote. So horizontal asymptote, remember it depended on the degree of the numerator and denominator. Another way that we could look at asymptotes was looking at the limit as x goes to positive infinity and the limit as x goes to negative infinity. If I look at the limit as x goes to positive infinity of the x squared minus x minus 2 all over x squared minus 2x plus 1, and we plug in infinity for all those values, we got infinity over infinity. So infinity over an infinity was another indeterminate form that didn't tell us anything about the limit, and that's where we had to go back and manipulate it. The trick was looking at the degree of the denominator, in our case, x squared, or square, or 2. We're going to divide everything through by that variable raised to that degree. So we're going to divide everything through by x squared. So x squared times 1 over x squared, that's 1, minus x over x squared, that would give us 1 over x, minus 2 times 1 over x squared is 2 over x squared, all over, and doing the same thing, distributing to the denominator, x squared over x squared is 1, minus 2x over x squared, that would give us 2 over x, plus 1 over x squared. So we're using the fact that the limit as x goes to infinity, and actually plus or minus infinity, of 1 over x to the n is equal to 0. So this 1 over x piece as x goes to infinity goes to 0. This 2 over x squared piece as x goes to infinity goes to 0. And so anything over x as x goes to infinity goes to 0. So all we're left with is the limit of 1 over 1, which is 1. So we have a horizontal asymptote at y equals 1. So I know with this graph here at 1, I have this horizontal asymptote. And so this is going to be crossing the x-axis somewhere, and I could figure out what those x-intercepts are. It's what sets my numerator equals 0. That's when my y value is 0. So x equals 2 and x equals negative 1 are the x-intercepts. So this was positive 1. This is not to scale. Let's say this is 2. Oh, it's okay. And then negative 1. I said negative 1, but I wrote 1. I believe I said negative 1.
Yeah, you said negative.
X equals negative 1. Okay. So that's crossing there. like this. And I can find my y-intercept. I can even get closer. Let x equal 0. I would get -2. Get the idea. And then it crosses here. It looks like this. So we're using limits as they go to positive infinity and negative infinity to find our horizontal asymptotes, looking at values which set the denominator equals 0, but not the numerator, to give us our vertical asymptotes. And then we can look at left-hand side and right-hand side limits of a vertical asymptote to see which direction it's shooting off towards, positive or negative infinity. So just a couple of other things, because I know we're not going to have time to go through everything that you should be able to do. So given a graph of a function, piecewise function, you should be able to find limits. So you should be able to look for left-hand limits, look for right-hand limits, and then just limits in general. So if your left-hand side limit and your right-hand side limit are not the same, when you're looking at the graph, they're approaching different y values, that limit does not exist. And so you'll have a question where you'll have a graph and you'll be asking or answering different questions about limits for that. You should be able to show that a function is continuous or not continuous at a particular value, and showing if it's not continuous, which condition doesn't hold. And if it's continuous, you're going to show that all of those conditions hold. Why know what else? You should be able to find that first section that we looked at when we first covered material. You should be able to find the instantaneous rate of change at a particular value and the equation of the tangent line. At that value. I'm thinking that we pretty much hit everything. Any questions? So right now, making the exam, it's 19 questions and you have 75 minutes to take it. So some of those should come out really, really fast. You know, looking at a graph, you should be able to find limits pretty fast. And so just being comfortable with all these different cases, if you get an indeterminate form 0/0, how do I manipulate that? What type of function is it? Can I factor? Do I clear the complex fractions? Do I get rid of the radicals? So all those different methods that we kind of looked at and how we can manipulate indeterminate forms of 0/0.